Now, I've been picking like the easiest circle I can pick, right? Center, 0, 0, radius is 1. So let's pick a new circle. Let's pick a circle that has a center of 2, 3, and a radius of 5. That's what we're going to do. And the easiest thing to do here is to graph that, and then we'll talk about the equation of it. So hopefully I have a piece of paper out and ready to go. I'm going to give myself a y-axis here and an x-axis. Close enough. And then let's see. So I'm just going to scale each of these is going to be 1. So that right there would be x equals 2, and up here would be y equals 3. So sometimes it's a good idea to label your axes a little bit. So if you look back at it later, it makes a little bit of sense. So that's going to be my center. And then the radius is 5. So I could just hop out here 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the left. And from here, I could go up 5 and down 5. So those are 4 points on my circle. So 2 plus 5 puts me over here at 7. 2 minus 5 puts me over here at -3. 3 plus 5 puts me up here at 8. And 3 minus 5 puts me down here at -2. All right, so I've labeled enough so that someone can look at this later and get a rough idea of what the heck I was doing. Now the exciting part here is, can I draw a reasonable circle through those points? And this is my best circle today after 1 cup of coffee. Not bad. We're going to go with it. So that's my circle right there. Now, this circle has a ton of other points. How many? Well, really infinitely many. So I'm just going to pick one of them. How about we pick a point over here? Let's be a little bit different today. Let's take a risk. That point right there from this central point here is exactly 5 units away. So I know r equals 5 to get from my center point to that point there. I don't know the coordinates of that point yet because I just kind of threw my pen down there, right? So it's kind of some random point on the circle. So I'm just going to call it xy. What do I know about that? Well, I know that to get to that point right there, right, I would have to go over whatever x is and up y. Now I'm going to look at this a little bit different. There's another way to get that point. To get to that point, from the center here, I'm going to go left. Oops, let me get a better left drawing tool. I'm going to go left a certain amount. And then I'm going to go up a certain amount to get to that point. And when I do that, I draw a right angle. Oops. So there's my right angle. Now, this distance I went left is not my x value, right? X value is the distance from here over to there. That is x right there. And that y value, that's not this height right there. It's the distance from here all the way up to there, whatever that is. Now, it looks like it might be around 6, but I don't know for sure. If we zoom in, it probably won't be exactly 6 for the y value. So what do I do with this right triangle here? Well, if I think about this circle a little bit more, to get from here to here, I had to go from 2 to whatever that x value is. So if somebody says, can you tell me what that distance is right there? I can look at this and say, yeah, it's whatever x is minus 2, right? It's the difference between those two numbers down here. It's that distance right there. So one of my legs has a distance of x minus 2. The other distance is the distance from this, the height of that central point, up to that y value, right? So that's this distance right here. And that's just this y value minus that y value. So that other leg has to be y minus 2. And Pythagorean theorem says measure each leg. So here's the measurement of one leg, x minus 2, square it. Add that to the other distance squared, and that has to be equal to the radius squared. All right, so that's the legs. This is the hypotenuse. That's my a squared plus b squared equals c squared. So the Pythagorean theorem again comes to my rescue and gives me the equation of this circle right there. And I lied. Y is supposed to be 3, isn't it? So if I make a mistake and you guys are watching, please say, hey, Parker, I think that was supposed to be a 3 for the Y value. Oh yeah, you're right. Good job. Thank you for pointing that out. So x minus 2, right? That's the distance from here to here. Y minus 3, that's the distance from here to here. And then I know the radius here has to be 5. And so there's the equation of my circle. Let's go to a graphing program and see if that actually looks kind of like the circle I drew right here. So I should expect to see, for example, an x-intercept over here of around 6.5-ish, if my picture is reasonably accurate. I should see another x-intercept here, pretty close to -2. And then I should see y-intercepts of around, what, 7.5 up there and -1.5 down there-ish, around. Let's check it out. So go to the graphing calculator of your choice, whether you decided to try GeoGebra or Desmos. So let's see, I'm going to do Desmos again. And sometimes if I have a bunch of stuff here and I'm just done with it, I'm just going to reload the page and say, yeah, please reload. Let's just start over. All right. Typing these things accurately is important. So let me see. I was saying x minus 2. And I was hoping somebody would argue with me about that x minus 2. Does anybody want to argue with me about that? There's a reason to. Parentheses, y minus 3, I almost mistyped it again, close your parentheses, raise that to the second power. And again, if you're trying to use one of these apps when I'm using it, or watching it in the video and it's not working the way it is for me, then make sure you ask or send me a note saying, hey, how did you make that work again? Equals 5 squared, which you could either just type 5 squared or hopefully you remember, hey, that's 25 on a good day. So that should be my circle right there. And according to my sketch, which was a little sketchy, I was thinking the 1x intercept was over here between 6 and 7. And if I go to my picture, ooh, it's supposed to be 6. Oh, I'll have to check that out. I'm quite a bit off there in my picture. I tried, I did my best. This one up here, y-intercept is around 7.5-ish. And how did that look in my picture? Yeah, that wasn't bad. Okay, so I did pretty good on this one, not so good on that one over there. So does my sketch seem close to the computer sketch? Close enough, right? Maybe you guys are better math artists than I am. I've been doing this for years, but on these digital screens, it's much harder. I find it harder to draw than on real paper. I like real paper better. So there's my circle right there. All right, so what we're going to do next is we are going to confirm some of these intersection points. Like, how would we check for sure? Now, the computer says it's 6 for the x value. Up here, the computer says it's 7.583. Is it exactly 7.583? Or is it, are there other decimals it's not showing me? Well, I don't really know. Let's find out. So we're going to go for the y-intercepts in this one right here. All right, so that was graphing a circle. Now we're going to take it just a step farther.